All right, everybody. So we are going to start to learn something new. This is so exciting. So make sure, grab your calculators and take this function, except we're going to store it into y1. Okay, so let's do that first. And we're going to change the x's to use parentheses, change the n's to x's. So I'm going to do that too while you're working. So 2x squared minus 3x plus 1 divided by, and then if you have the older calculator, make sure you use parentheses, x squared minus 1. If you have the newer one, it's better. Okay. So when we were in chapter 13, we actually kind of did that last. We were thinking if this is a sequence, you can generate the terms. And what's special about this rule? This is a rational function. And you know that at the ends, that function behaves like the ratio of the leading terms. So we just kind of wrapped this. This year we did this last. In years past, we did it as part of chapter 13. So that function only at the ends is pretty darn close to 2n squared over n squared, but that reduces, and so this limit is 2. Okay, so that's kind of where we ended up the last couple lessons. Okay, so now we're going to do something different. Okay, we're going to expand our thinking, and here's the things that we are going to be thinking more sophisticated about. Okay, so first thing is, the input is just a real number now. It's x. We're not generating a list of terms. We're just thinking about a function. Okay? And so we're not thinking about x. And we can still look as x gets really big, but sometimes we can think about x going to a particular number. In this case, we're going to the number 1. Okay? And if you think about a number line, let me draw a number line for you guys. Okay, so just think about a number line. Before we were thinking about the terms as they get really, really far to the right. Okay, now we're going to thinking about the output of the function when we get close to a particular number, say the number 1. And the question is, we're going to get close to the number. We can have two different things. We can come at the number from the right, or we could come at the number from the left. We didn't have that choice when we were looking at things getting bigger because we're only moving to our right. Okay, so we are going, so this notation means, and the way you read it is the limit as x approaches 1 from the right. Okay, you want to find what the expected outcome of the function is at 1 as you approach from the positive side or from the right. We call this a one-sided limit. Okay? Okay. So here's what we're going to do as we sort of start to discover. We're going to pick some numbers since we want to come at 1 from the right. We're going to pick numbers that are a little bit bigger than 1, but getting closer to 1. So here's my numbers. Okay, now why did we bother to pick 1? Okay, well, if you try to find f of 1, that function at 1, what would happen in the denominator? You would have 1 squared minus 1, and you will get 0. So you can't actually get an output at 1. That's what makes looking at limits kind of interesting. Okay, so now I looked on the internet for a YouTube video, but they all do it different than me. So I like to do it this way. So everybody's got this function is in y1, right? Okay, so go to your home screen. Okay, and remember we use the variable key. So go to the variable key. It says var. Variables, go to y variables. That's a function. And grab where it says y1. And from your home screen, you're going to have it type in y1 of 1.1. So everybody take a second and do that. You want to say y1 of 1.1. We've done that before. And then you press enter. My calculator tells me that's 0.5714 and some change. So 0.571 plus some little bit more. Now, it's super easy because you can either pull back the line or do second enter and just change 1.1 to 1.001. So we've got to go and add a couple more zeros in there. and press enter again. And this time I get 0.5007 and some more stuff. Okay, and now do with the next one. And this time I get 0.5, a whole bunch of zeros. And I'm going to work however they are. I got a 75 at the end of my calculator. And what I notice is that the closer I get to 1, the closer these numbers get to a half. They're pretty darn close to 1/2. I bet if we kept on adding some more numbers, eventually my calculator would either make an error or tell me it's 1/2. So we know that the limit as x approaches 1 from the right of that cool function is 1/2. Okay. Well, it makes sense then that maybe we want to look at what happens as we approach 1 from the left. Okay, and the way that looks is there's still the 1 here, but you put like a little negative, because the one way to think about it is that let me erase that. Actually made it a little too dark for you guys, huh? Okay. Is you're taking a number that's 1 minus something, but most people think of it you're coming from the left. Okay, so if you were going to do some numbers, if you're going to make a table like this again and you want to check this limit, what would you check? Well, you're coming at 1 from the left, so maybe 0.9, maybe 0.99. You don't want to get too many digits because sometimes then your calculator will have a round off error. So let's do the same thing. And since we already have that function in there, just change where we had the 1.0 something and put a 0.9 in there. And I'm doing that on my calculator, and I got 0.42. And then I call that back up, type in another 9, I get 0.492 and a whole bunch of stuff. And then I do another 9, so 0.999, and now I've got 0.499 and some more decimals. So you can see as this gets closer to 1, these numbers are getting closer to 1/2. And that's really the big idea here. So the limit as x approaches 1, this time we picked inputs from the left, is also 1/2. Okay? Okay, let's look to the next page. Okay, so this time I did the opposite. I gave you a table, and I want us to write the limits. Okay, so let's see. So where are the x's approaching, and what's happening to the outputs? These numbers are getting, you sometimes even think about it graphically. You're here, then you're here. You're getting super close to 0, and these numbers are getting super close to 1. So let's see, we would write the limit as x approaches 0, but these numbers are a little bigger than 0. So we say from the right of the function sine x over x, those outputs are getting closer and closer to 1. Now, why is this an interesting thing to look at? Like, why bother, Miss Brady? Who cares? Because if that's the function, you can't evaluate that at 1, right? If you tried to literally put in sine of 0 over 0, you can't divide by 0. So this doesn't have an output. Like, this is not equal to 1. But if you pick numbers super close, you would think that you are going to get approach 1, but you just never hit it. Okay, let's try one more. So a two-sided limit at a particular value, that won't have the plus or minus subscript. So if you look at this notation, you see there's no it's not saying x approaches 1 from the plus or x approaches 1 from the minus. It's just saying x approaches 1. So that's called a two-sided limit. Okay, it's not true if it's infinity because you only can get to the ends from one direction. But if you got some real number value, you can approach from either direction. Okay, so if we're going to make a table, we should probably look at both sides then, right? Okay, so let's do x let's say f of x is this crazy function. You're going to learn this next year, that this is one of the ways to think about a derivative. You know, I like to do some preview. Okay, so let's be sneaky, not be sneaky or be thoughtful. Let's take and let's change that. Let's go back to your calculator and put that into y1. So the number e to the x minus the number e. And the regular e is the blue, the second on the divided sign, if you haven't used that yet. And then divided by x minus 1. Okay? And again, why do we care to look at 1? Like, who cares? Why do we care? Because at x equals 1, this output doesn't exist. Okay, that's why mathematicians invented limits, because we're going to start to look at things where we would expect some number to come out, but it just doesn't. Next year, you can do a lot with slopes. Okay, so let's see. So if you want to approach, let's see. If we want to approach 1 from the right, we need numbers that are bigger than 1, just a little bigger than 1. So how about 1.01, 1.01, 1.001. When I looked at the videos online, they all do tables, but to me, I like to do it with the y1. So you change that to y1. So we just can do y1 of 1.1. I get like 2.8588. And then I just do second enter. I'll go grab it. I change that to this input. I get 2.7319, a whole bunch of decimals. I'm going to do 0.01. Does anybody recognize that number? I hear ya. You're like, oh, I think that's going to E. Now, which numbers would you pick from the other side? If you're going to go x getting closer to 1, but from the left, it means you want numbers that are a little bit smaller. So how about let's just do 0.99 and 0.999. Okay, and again, we've got that function in there, so we can just do second enter, call that back up, and I get 2.704 something, and then I get pretty close to E. Okay. Okay, so we're just using our calculator skill, our numeric skill, to show that we think the limit as x approaches 1 of the function e to the x minus e over x minus 1 is worth e. Yay!